Okay, so uh, you ever get this feeling like when your phone is acting up and you just like you're convinced it's a conspiracy or something? Like there's no way all this technology can be this glitchy.
Yeah.
Well, I recently went down the rabbit hole with this document that you sent over, all about antenna requirements. And let me tell you, it's not magic, but it is complex.
Oh, it really is. We really take for granted how much engineering goes into making sure our devices can send and receive signals flawlessly, all while like playing nice with literally everything else in the world.
Right? So this document, it kept mentioning these three big players,
Right.
the FCC, 3GPP,
Yeah.
and of course, our buddies, the wireless carriers. Like they each have their hand in the wireless cookie jar. Yeah.
That's a great analogy. And it's important to understand each player's role because their influence overlaps and sometimes even clashes. The FCC, they're like the referees here in the US. They're ensuring everyone's playing fair, that devices aren't causing harmful interference with each other.
So no rogue radio waves messing with air traffic control.
Great.
Got it.
Yeah.
But what about this 3GPP thing? That one sounds a little mysterious.
It does right. 3GPP stands for the Third Generation Partnership Project, and it's basically a bunch of engineers from all over the world deciding on the actual technical standards for wireless communication. They're the ones setting the rules of the game, so to speak.
Ah, so they're making sure my phone can still send cat memes, even when I'm on vacation in a different country.
Exactly. Without them, we'd have a chaotic mess of incompatible devices. But then on top of the FCC and 3GPP, we have the carriers themselves.
Which, if we're sticking with the sports analogy, are kind of like the team owners. They've got their own turf and their own rules on top of everything else.
You got it. Carriers have a vested interest in making sure any device on their network meets a certain performance standard, so they layer on their own tests and requirements. All of this directly impacts things like your coverage quality, data speeds, even your battery life.
So wait, just to be clear, a phone maker has to jump through hoops with the FCC, the global 3GPP, A&D, the individual carriers before it even hits the shelves. That's intense.
It is. And you'd be surprised how often these different interests collide. For example, a carrier might want to launch a new technology quickly to get ahead of the competition, but the FCC might pump the brakes to ensure it doesn't cause interference problems. Or 3GPP might be working on a global standard for something, but individual countries might have their own regulations that complicate things.
It's like a three-way tug of war with our tech stuck in the middle.
It can be. But understanding this dynamic is key to understanding why the world of wireless can feel so complicated sometimes.
All right, so we've got these three titans of the wireless world, each with their own agenda. But what does it actually look like when a phone has to prove itself? This document was full of tests with names I barely understood, like it was alphabet soup or something.
Yeah, it's a whole battery of tests, literally.
Okay.
And some of the names do sound like they're straight out of a science fiction novel, but they all boil down to making sure your device can handle the airwaves.
Well, speaking of science fiction, one phrase that caught my eye was radiated emissions. Sounds a little alarming, to be honest. Like, is my phone leaking something it shouldn't be?
I can see why you'd think that. It does sound a bit ominous. But think of it this way. Every wireless device is essentially a mini radio station sending and receiving radio waves.
Okay.
Radiated emissions is just a fancy way of saying we need to make sure those radio waves aren't causing unintended interference.
So, like, my phone shouldn't be messing with my Wi-Fi signal or causing the TV to act up.
Exactly. The FCC sets limits on how much radio frequency energy a device can emit, kind of like setting noise limits in a residential area. It's about ensuring everyone can use their wireless gadgets without stepping on each other's toes, so to speak.
That makes a lot of sense.
Hmm.
Okay, then there were these acronyms, TRP and EIRP. They kept popping up in the document. What's the deal with those?
Those are all about a device's transmitting power, or how strong its signal is. Imagine you're at a crowded party. EIRP, or effective isotropic radiated power, is like the absolute loudest you could shout to be heard over everyone else.
Right.
TRP, or total radiated power, is more like your actual speaking volume, taking into account the direction you're facing and any background noise.
Okay, so it's like the difference between, like, theoretical maximum volume and real-world volume. But why does it matter?
Well, if your phone signal is too weak, your calls will drop and your internet will crawl. But if it's too strong, it could interfere with other devices, and you might even run afoul of those FCC regulations we talked about.
So it's a delicate balance. Now, this is interesting. The document also mentioned testing how well devices receive signals, not just transmit them. Why is that important? I thought it was all about, like, sending out a strong signal.
That's a common misconception. It's a two-way street. Just like in a conversation, being a good listener is just as crucial as being able to articulate yourself. And that's where TIS and TRS come in.
More acronyms. Hit me with your knowledge.
So TIS stands for Total Isotropic Sensitivity, and it measures how well your device can hear even the faintest signals. Think of it like this. You're in a bustling coffee shop trying to have a phone conversation.
Okay.
A phone with good TIS will be able to pick out your friend's voice from all the background chatter.
Okay, so a higher TIS means better reception in areas with weak signals. That's huge.
Absolutely. Now, TRS, or Total Radiated Sensitivity, is similar, but it looks at the entire system sensitivity, not just the receiver itself. It's a more holistic measure of how well your phone, with its antenna and all its components, can pick up those weak signals.
Got it. So we've got these tests to make sure our phones can speak and listen clearly on the airwaves. What else is there?
Well, all these tests we've discussed so far are typically done in a controlled lab environment, but we don't live in a lab, do we? The real world is a messy, unpredictable place full of concrete, metal, and other things that love to mess with radio waves.
Right, which is where I'm guessing this OTA testing comes in, right?
Yeah.
I remember that from the document.
You got it. OTA stands for over the air, and it's all about making sure a device can function in the wild, so to speak. This can involve simulating all sorts of real-world scenarios.
Like stuffing the phone in your pocket and walking down a busy street. Or trying to make a call while crammed on a subway with 100 other people.
Exactly. They even have these specialized chambers that mimic different environments, like a crowded sports stadium or a rural area with weak signal strength.
Wow, so it's like boot camp for your phone. They put it through the ringer before it's deemed worthy of our pockets.
It's a rigorous process for sure. But these OTA tests are crucial because they reveal issues that might not show up in a pristine lab setting.
This is all fascinating stuff, but I have to ask, why should we, the average phone users, even care about any of this? I mean, it's great that engineers are making sure our phones work, but how does it impact us directly? Okay, so we've got the FCC, 3GPP, carriers, all these tests with crazy names. It's like trying to follow a game with a million rules. So for everyday people like me, what's the takeaway here? What does it all mean for us?
Well, at the end of the day, it's all about that device in your pocket, right? All this complexity, all these tests, it's all designed to make your actual user experience better.
Okay, I'll bite. How does this alphabet soup of acronyms translate to like a better phone call or something?
Let's take something we all care about. Battery life. Ever notice how your battery drains faster when you're in an area with a weak signal?
Oh, tell me about it. It's like my phone's main purpose becomes finding a signal. Forget actually using it.
Exactly. When your phone has to struggle to find a signal, it has to work harder, and that gobbles up battery life. Those tests we talked about, especially the ones measuring signal strength and receiver sensitivity, those are crucial for ensuring your phone doesn't become a battery-draining black hole in weak signal areas.
So stronger signals, thanks to these tests, equal more time I can spend, scrolling cat videos before I need to find an outlet. I get behind that.
Precisely. And it's not just about staying connected locally either. Think about traveling internationally. Remember 3GPP and how they set those global standards? That's why you can get off a plane in a totally different country, and your phone just magically knows how to connect.
You know what, that ice is pretty magical when you think about it. I never really considered that it's because of all these behind-the-scenes agreements between all these different companies and even countries.
It really is a remarkable feat of coordination when you think about it. And it ensures that these devices are all speaking the same language, regardless of where they were made or where they're sold. It's like the universal translator of the tech world.
Okay, that's pretty cool. But doesn't all this testing and coordinating slow things down? I mean, new phone tech seem to come out like every other week these days.
That's a great point. And yes, there is a certain trade-off there. Sometimes these rigorous testing processes can mean that a new technology might take a little bit longer to hit the market. Remember, OTA testing, making sure a device can work out in the real world, that takes time.
So it's like a necessary evil. We wait a little longer, but at least we're not all out here beta testing buggy technology in our daily lives.
Exactly. It's like quality control, but on a global scale. And when you think about the sheer number of devices out there, all relying on the same airwaves, it's crucial to have a system in place to prevent, complete chaos.
Chaos on the airways. Yeah, no thank you. So to bring it all back, these regulations, these tests, they're kind of like the unsung heroes of our connected world, making sure that the tech we rely on actually works as advertised.
That's a great way to put it. They might not be glamorous, but they're the invisible forces that keep our digital lives running smoothly.
I've got to admit, I started digging into this document feeling a little overwhelmed by all the jargon and technical details, but now I see it's all about making our lives easier, even if it's all happening behind the scenes. Finding that sweet spot between, constant innovation, but also making sure the tech we rely on actually works. Who knew?
It's all connected, isn't it? And sometimes taking a deep dive into the how and the why can give us a whole new appreciation for the things that we just take for granted every day.
Absolutely. So for everyone listening, next time you're effortlessly streaming your favorite show or hopping on a video call without even second thought, take a moment to thank those invisible forces, the regulations, the tests, the engineers, all those people working behind the scenes to make it all possible. They really are the silent guardians of our connected world. And on that note, we'll catch you on the next deep dive. Until then, happy surfing those airwaves.